Hello everyone. So this is the next video on the chapter 2. We discuss the monotonic sequences. So what is monotonically increasing sequence? In a sense, if the terms are increasing A1, A2, A3, A4, that means A1 is less than A2, less than A3, less than A4. Equality is there, it may be equals also. Then we say that it is monotonically increasing. Monotonically decreasing means this must happen. This must be A1, A2, A3, A4. That means A1 is less than or equals to A2, less than or equals to A3, less than or equals to A4. Then it is called monotonically decreasing. The example is xn equals to n, it is monotonically increasing. xn plus 1 equals to 2 plus an, where an is positive, this is also increasing, or else xn equals to root n, this is also increasing. Monotonically decreasing, xn is equals to minus n, minus n is decreasing. xn equals to 1 by n, this also decreasing. Likewise, xn equals to 1 by n square, that is also decreasing. Now, strictly means you will have, instead of this equals to, you will have a1 less than a2 less than a3. If this happens, it is strictly monotonically increasing. If getting strictly monotonically increasing, here I written a moment, a1 must be greater than or equals to for this. Sorry, I mistakenly written. For monotonically decreasing, a1 must be greater than or equals to a2, must be greater than or equals to a3. For strictly monotonically increasing, a1 less than a2 less than a3, this should happen. Strict inequality should be there. Then we say that it is strictly monotonically increasing. If a1 is greater than a2 greater than a3, then we say that it is strictly monotonically decreasing. Again, a monotonic sequence is convergent if and only if it is bounded. If you have a monotonic sequence, so it's going likewise. Let me assume the sequence is going. So somewhere if you find a bound, it won't cross this, so you will have limit. Or else if you have a monotonically decreasing sequence, somewhere you can find the bound. If it is bounded below, you can find the limit of that sequence. So a monotonic sequence is convergent if and only if it is bounded. If it is unbounded, what it will do? See, let me say a sequence is increasing. If it is unbounded, just it will increase. So it is divergent. That means if you have the bound, it will converge. If it is unbounded, it will diverge. That means either it will converge or diverge. That means there is no possibility of oscillatory. That's why monotonic sequences are never oscillatory. One more thing. Convergent sequence need not be monotonic. A monotonic sequence is convergent if and only if it is bounded, that is fine. But if I have the convergent sequence, it need not be monotonic. Example is this. 1 minus of minus 1 to the power n by n. This is not monotonic, but it is convergent. As n tends to infinity, xn converges to 1. Clear? Sixth one is, if k is greater than 1, k to the power 1 by n is monotonically decreasing. If k is less than 1, k to the power 1 by n, that is nth root of k, it is monotonically increasing. And nth root of n is monotonically decreasing for n greater than or equals to 3. Is it clear? Nth root of n is will monotonically decrease if n is greater than or equals to 3. Now, this is interesting. x1 is non-zero and xn is defined to be this. xn plus 1, 1 by 2, xn plus k by xn. Then xn will converge to either root k or minus root k. xn will converge to either root k or minus root k. But when it will converge to root k, it will converge to root k if x1 is given non-zero. No, if it is positive, it will converge to root k. If it is negative, it will converge to root minus k. For example, you try the same example. Xn plus 1 equals to 1 by 2 into xn plus 2 by xn, provided x1 is positive. If x1 is positive, it will converge to root 2. If we had given x1 less than 0, it converges to minus root 2. How to do this? I will give you the hint. You say if xn converges to L, xn plus 1 will also converge to L. So you instead of xn and xn plus 1, you would substitute L. L equals to 1 by 2 into L plus 2 by L. You will get a quadratic equation where L square equals to 2 you will get. So L square is L is equals to plus or minus root 2 you will get. You will get L square equals to 2. This implies L is equals to plus or minus root 2. Whether to take plus root 2 or minus root 2 will be decided by the given condition. If x1 is given positive, you take root 2. If x1 is negative, you take minus root 2. Clear? Okay. And this is the Euler's constant, which is given by this, and it is convergent. Clear? Next is how to evaluate some limits. We have some standard theorems. The first theorem is squeeze principle. Squeeze principle in the sense, see here, it's also called sandwich theorem. In the sense, middle fellow will be there. Here I have one fellow and here I have one fellow. That is, here I have xn and yn. Let me say this is zn. And if xn is converges to L and yn is converges to L, and you have this zn is sitting between xn and yn, then zn also will converge to L. If xn converges to L and yn converges to L, provided if this is the situation that zn also converges to L. That is the squeeze principle. Again, xn be the sequence such that xn is non-zero. For all n it is non-zero. If xn plus 1 by xn is, the limit is L, and if the bound of that L is less than 1, then xn will converge to 0. You should observe this carefully. The next result is similar, but one thing you need to observe in a keen, you should observe it keenly. Xn be a sequence such that here he had given xn is not equals to 0, but he is telling xn is positive. Then he had given same thing, but L is greater than 1. Then this will work. If we had given xn is not equals to 0, we are not sure. But if xn is not equals to 0, if L is less than 1, definitely limit of xn is 0. That is fine. But instead of this, if he gives xn is does not equals to 0, then we cannot conclude this. That will work if xn is positive. Because if it is tending to infinity, means the terms must be non-negative. If it is less than 0, it may go to the sentence to infinity, it may diverge to minus infinity also. We don't know. That's why in order to say infinity, that is signified by this, xn must be positive. Cauchy's first limit theorem on arithmetic mean is, see, if xn converges to L, its arithmetic mean also will converge to L. That is x1 plus x2 plus etc. xn by n also will converge to L. The converse is, if this happens, does it implies xn converges to L? Getting my point? The Cauchy's theorem says if xn converges to L, its arithmetic mean also will converge to L. Arithmetic mean is x1 plus x2 by xn divided by weight. How many elements are there divided by that weight? That will give me the arithmetic mean. That will converge to L. Whether the converse is true, that is, if x1 plus x2 plus etc. xn by n converges to L, can I say xn converges to L? That is the question. Converse, sadly, it is need not be true. Why? I will give you an example. Xn equals to minus 1 to the power n. Whether, look to this. See what is, I need to come from this. x1 plus x2 plus etc. xn by n. How does this will look like? Take only 3 terms. Let me say x1 plus x2 plus x3 by 3. So what is x1? x1 is minus 1. x2 is plus 1. x3 is minus 1 by 3. Minus 1 plus 1 will get cancelled. So minus 1 by n. If n is odd, you will get minus 1 by n. Right? If n is even, you take only 2 now. Minus 1 will go with plus 1. So you have 0. If n is odd. That means this arithmetic mean is either minus 1 by n or 0. What will happen to its limit as n tends to infinity? As n tends to infinity, minus 1 by n will tend to 0. This is already 0. So this will tend to 0. Getting? This is convergent to 0. But what can you say about this xn? I am coming reverse. Converse means this is converging to 0. Whether this will converge to 0? Xn equals to minus 1 to the power n is not convergent. So converse need not be true. Similarly, we have one more result. If an is positive, because why I am taking a1 to be greater than or equals to 0? Because I am taking within the square root. And if limit of an is L, then nth root of an, a1, a2, etc. up to an is also equals to L. Idea is clear? Its geometric mean also will converge to L. Now Cauchy's second limit theorem. This is interesting. A and B the sequence of positive terms. Why I am taking positive terms? Because I am taking them within the nth root. So it must be positive. Then limit of n tending to infinity, that will be equals to limit of n tending to infinity an plus 1 by an. This we will usually do while discussing the radius of convergence. However, this is valid if the RHS exists. Whether it is finite or infinite, it must exist. Then we say that nth root of an equals to this. Is it clear? The right hand limit should exist. So if an is a sequence of positive terms, nth root of an will be this. How about the converse? Converse of Cauchy's second limit theorem is not true. Example is this: 2 to the power minus n plus minus 1 to the power n. What else it says? Nth root of xn. What is nth root of xn? It is 2 to the power minus 1 plus minus 1 to the power n by n. As n tends to infinity, it is 1 by 2. Clear? But what is xn plus 1 by xn? It is 2 to the power minus n plus 1 plus minus 1 to the power n plus 1 by 2 to the power minus n plus minus 1 to the power n. This will be equals to 2 to the power minus n minus 1 plus minus 1 to the power n plus 1. I will take these things to the numerator. So you will get plus n minus minus 1 to the power n. So this will go with this. Getting? So this depends upon the n what else you are choosing. If n is even, what will happen? If n is odd, what will happen? If n is even means minus 1. If n is even means I will get 2 to the power minus 1. This is even plus 1 is odd, so I will get minus 1 again. Minus of, if I get this minus 1 to the power, so I will get minus 1 again. That is 1 by 8 if n is even. If n is odd, 2 to the power minus 1 plus minus 1 to the power 1 plus 1, let me say. So it is 2, that is it will give, I will get 1 itself. Then again here minus of 1. This will go with this. So it is 1 by 2. So I am getting 1 by 8 in the other end, 1 by 2 in the other end. So it is not, that's what, RHS must exist. The converse of this Cauchy's second limit theorem is not true in general. That means if this is true, if I am telling if this happens, this will work. But how about the converse? This is agreeing, but the RHS is, if RHS exists, then only the game will work, or else we cannot conclude anything, whether it is finite or infinite. See, here I am getting finite only, but still it's not equal to, they are not, the limit does not exist. Getting my point? So converse of Cauchy's second limit theorem is not true. Next is Cesaro's limit theorem. It says if an converges to a and bn converges to b, write them in this way: a1 bn, a2 bn minus 1, a3 bn minus 2, etc. an b1 by the weight. Weight is how many terms are here? 1, 2, likewise n terms are here. This will converge to ab. Is it clear? Stohl's theorem. This is interesting. Xn is any sequence, yn is monotonically increasing, and yn tends to infinity must be there. I repeat, xn be any sequence, yn is monotonically increasing and yn tends to infinity, then if limit of xn minus 1 by yn minus 1 is L, if it exists, then limit of xn by yn is L. Is the idea is clear? So this is Stohl's theorem. Again, if limit of f of n and g of n is infinite, then 1 plus 1 by f of n by g of n is e to the power limit of g of n by f of n. This we will use while solving the problems. These things we will use, and this is the expansion for log. In between we will use this. Kindly look down into these things. Then this is the hierarchy which dominates. N to the power n is always greater than n factorial, and n factorial is greater than k to the power n, k to the power n is greater than p to the power n, p to the power n is greater than log n. This idea is clear? So whenever we have n factorial by n to the power n, to what it will converge? Which is dominating? This is larger. N to the power n is greater than this. So larger value divided by, you have larger value in the denominator means it will converge to 0 as n tends to infinity. Getting? Or else k to the power n by n factorial. N factorial is greater than k to the power n, so this will converge to 0. Or else you take in this way. What is n to the power n by n factorial? N to the power n is dominating n factorial, so this must converge to infinity. It must diverge to infinity. How about this case? N factorial by k to the power n. Since n factorial is dominating k to the power n, so that means numerator is larger. This diverges to plus infinity. Idea is clear. So next is we try to look into this example. I need to evaluate this limit 1 by n square plus 1, 1 by n square plus 2, etc. 1 by n square plus 1. So for this I use the squeeze principle. Let me say this is an. I need to find where it is lying down. So an is less than or equals to what it is less than or equals to. If it is less than or equals to means, that means I need to find the largest element here. What is the largest element here? The denominator must be smaller. For which value the denominator is smaller? For this value. Right? How many entries are there? 1, 2, likewise n entries are there. So it is less than n into square root of n square plus 1. That's what you do. It is less than 1 by n square plus 1 plus 1 by n square plus 1 plus etc. 1 by n square plus 1. N times it repeats. I written it directly. Again, this is less than or equals to what? That is an is greater than or equals to. I need to find the smallest one. Smallest is this. Denominator must be largest. So it is n by square root of n square plus n. So take the limit. So this will be, if I take n, so it is 1 by 1 square. If I take here, it is n by, so as n tends to infinity, this will converge to 1. As n tends to infinity, this will converge to 1. So an is lying between 1 and 1. That means by squeeze principle we can say this converges to 1. So the limit is 1 for this. Did you understood the technique? So how about this? Whether it is convergent or divergent, or else to what value it will converge. So this is 1 plus 1 by 2, 1 by 3, etc. up to 1 by n. Look to this in this way. 1 plus a1 plus a2 plus etc. an by n. If an converges to L, then its arithmetic mean also will converge to L. That's what we observed in the Cauchy's first theorem. So an is 1 by n. 1 by n. Getting my point? 1 plus 1 by 2 plus etc. 1 by n. This is an. An is converging to 0. So weight is n here. So this will converge to 0. So option A. Again, 2 by 1, 3 by 2, 4 by 3 whole cube, etc. n plus 1 by. So this is a1, a2, a3, an. Right? Nth root of this. So already we know if an converges to L, its geometric mean also will converge to L. So to what an will converge? That is n plus 1 by n whole to the power n as n tends to infinity, to where it will converge. 1 plus 1 by n, 1 plus 1 by n whole to the power n. This will converge to e as n tends to infinity. So this will converge to e. Getting? Fourth is 1 by root n, 1 plus 1 by root 2, 1 by root 3 plus etc. 1 by root n. To what it will converge? Pause the video and just do it. According to you, see, this is a1 plus a2 plus etc. an by n. So root n is here. What you will do, if an converges to L, an by root n will converge to L. So 1 by root n will converge to 0. So you will say this will converge to 0. No. That is not the idea here. Because that's why I put it this simultaneously, to clear the confusion. The weight must be n. How many terms are there? That must be there. That is arithmetic mean. This is not arithmetic mean. So how to do this? Just take this in this way. We will use Stohl's theorem. What else we discussed? What else it said? Xn may be any sequence. Yn is monotonically increasing and Yn must be divergent. If that happens, you consider xn minus 1 by yn minus 1. If this converges to L, then xn by yn will converge to L. Now you take yn equals to root n and xn be the numerator. What else it is there? Xn equals to 1 plus 1 by root 2 plus etc. plus 1 by root n. Then what is yn by xn? First of all, you need to find this limit. If it exists, then that will be equals to xn by yn. So it will serve the purpose, because yn is increasing and yn tends to infinity. As n tends to infinity, there is no restriction on xn. So that will work. How to think about this? So just find xn minus 1 by yn minus 1. What is xn? Xn is 1 plus 1 by root 2 minus xn minus 1. That means you will get up to n minus 1 terms will get cancelled. You will get 1 by root n in the numerator. What is yn minus 1? It is root n minus 1. So it is 1 by root n into root n minus 1. You factorize this, right, into 1 by root n plus root n minus 1. So what else will you get? Root n plus 1. Here I will get root n into a square minus b square. So a square is n minus b square is minus of n minus 1. So you will get 1 here. So now take root n out here by root n. 1 plus, that is square root of n, 1 is there. So here I have 1 plus 1 by n. So root n will go with root n. As n tends to infinity, root 1 is 1 only. Here I have 1 plus root n. So it is 1 from this end plus 1 from this end. So it is equals to 2. This value is equals to 2. We will solve many problems and we will be clear with all these things. Thank you.